Welcome friends. This is Dr. Atul Dhale, Professor in Production Engineering Department from DJ Sanghvi College of Engineering, Mumbai. We'll see here the calculation of the greenhouse gases for the iron and steel production. First, we'll see what do you mean by the carbon footprint. Carbon footprint is a calculation of the cost of a product in the grams of CO2. So, for manufacturing of the product, how much the grams of CO2 emission is there? That is the carbon footprint. Now, there are number of factors involved in this. Now, if you take a just simple example of the bottle of the shampoo, so what are the different factors the greenhouse gases involved in the production of the plastic packaging? Plastic film used to wrap the bottle. When they are transported on a pallet, definitely you require the energy and produces the greenhouse gases. The ingredients in the shampoo itself and even the energy used to heat the water. So which factors we should consider or not, and that is given by the ISO 14067. So this 14060, this is the complete family of ISO and which provides the clarity and consistency for quantifying, monitoring, reporting and validating or verifying the greenhouse gas emission and the removal to support the sustainable development through the low carbon economy. So these are the different ISO standards of this 14060 family. So 14064, 1, 2 and 3. This gives the complete description. I will not go much in detail because we have to finish within 12 minutes. So this is the relationship between the ISO 14060 family, and this is the relationship between the document and standard beyond the greenhouse gases management family of the standards. So first, again we should know what do you mean by the greenhouse gases. The gases constitute of the atmosphere, both the natural and anthropogenic, that absorbs and emits the radiation at a specific wavelength within the spectrum of the infrared radiation emitted by the Earth's surface, the atmosphere and the cloud. The most significant greenhouse gases are the water vapor, carbon dioxide, methane and the nitrous oxide according to the Environmental Protection Agency, while the oxygen is the second most abundant gas in our atmosphere. O2 does not absorb the thermal infrared radiation. Now, why I have chosen this iron and steel production? The reason is, if you see the year on year growth of the CO2 emission and the dominant sector in the manufacturing sector, it is the iron and steel industry. You can see the lowermost, the red color part, which is almost the 30 to 40% creation of this CO2 emission. It is due to this iron and steel industry. So this shows you the different state, how the emission and the top 15 states in India. So you can see at the first one it is the Gujarat, Odisha, then Chhattisgarh, Jharkhand, Karnataka and Maharashtra, where this iron and steel industries are there. This graph shows you how the CO2 emission goes on increasing according to the per capita and the per unit GDP, and you can see it goes on increasing only. Here in this, there is an interesting information that CO2 emission, it is mainly, or you can say the most impactful, it is due to the coal in manufacturing industry. So other fuels have the less effect on this CO2 emission, but the coal is having the maximum one. So definitely we have to look after this. So when you consider the iron and steel production, there are two different methods for calculating the CO2 emission. The first one is the quantity of reducing agent and the blast furnace additives used, as well as the quantity of the carbonate fluxes introduced into the furnace. And the second one is the amount of iron or steel produced, as well as the carbonate fluxes. So directly it is related to the amount of iron. So emission calculation from either method can be adjusted to the account of the export of the carbon bearing by the product. So here in this diagram you can see how the iron and steel get manufactured, or this is the production process. You can see here there is a raw material which is iron ore, then the coal injection, then this is the coal, then coke oven byproducts, and then this is the input for the different furnaces. And here this is the, you can see the blast furnace, and then this blast furnace gives the some part of the pig iron casting, and some part goes to the basic oxygen furnace, and then it goes to the steel refining facility. And again from this side there is a electric arc furnace. So at every stage there is a emission of greenhouse gases. So you can see here in this schematic diagram, at every stage there is a, you can see the CO2, CH4, N2O here in this sinter plant. Then in the blast furnace again there is a greenhouse gases here in this steel make. So everywhere, and it is very impactful. So definitely, and as we have seen, whenever we are using the coal, that again increases the CO2 emission. So for calculation we required this, we should know what is the tires which we are using. Now generally some values which are globally accepted, some values it is maybe country wise, and some value it is at the local level. So that's why this tires, it is classified into three: tire 1 which we use the globally, then the tire 2 which is more specific than the tire 1, so it may be some specific countries, and the tire 3 it is very specific. The tire methods require the facility specific data, such as the composition of the fuel combusted at the facility, or at a specific type of technology employed at the facility. So now again, how to calculate this CO2 and CH4? There is a difference in calculation of when we calculate the CO2 and CH4. The CO2 emissions are largely determined by the carbon content of the consumed material, and the CO2 emissions are best determined using the material balance approach that tracks the flow of the carbon through the industrial process. Whereas for the CH4 and N2O, the emissions are much more influenced by the combustion or emission control technologies employed by the industrial apparatus. And also the CH4 emissions are best determined using the equipment or process specific emission. It is not related to the material, right? So now in iron and steel industry, which are the processes? So mainly stationary combustion. Under this stationary consumption there is a electricity generation or capitative power plant boilers, reheating furnaces, mill sections, coke production, and the flaring. And the industrial process emission, there is a sintered making, pelting, iron and steel making, and direct reduced iron for production. And the third one is the limestone and dolomite production. So for all this, how to calculate this CO2? See, in next 7-8 slides this gives you all the details, but I cannot go through each and every point. I will just show you the equations. So emission from the electricity generation and reheating, see, this is for the stationary one. So this equation 1 gives you the total annual fuel consumption, then fuel carbon content of the heating values. So this equation 3 again converting carbon content factors from a mass or volume basis to the energy basis. Then this calculation of CO2 emission, calculate this. Equation 4 gives you the calculation of CO2 emission. Equation 5 calculating the CO2 emission from the stationary combustion sources using the carbon content data exposed to the energy. Then this, now this is for the CH4 and NOx. Equation number 6, equation number, then see this table, this is for the tire 3. What are the material which you are using for this, and then accordingly that material and the basic technology, you will get this value. You can substitute that value in that equation. Even in the emission from the coal making, we can see this equation number 7, equation number 8, and this table. From this you will get the different values of the carbon content. Then the CH4 for calculating this, you can use this equation number 9. Then emission from the flaring, you can use this equation number 10. Calculation of CH4 for this flaring, you can use the equation number 11. So that up to equation number 11, this is the part of the stationary one. Then the industrial process emission, sintered production, you can use this equation 12, 13. All this equation gives you the CO2 emission, the CH4 emission for the different processes. And this tables, see, whatever the table it is given, these are all the standard values you can, because this values you required in the different equations which are shown you from equation 1 to equation 20, you can substitute that and you can calculate. Then the sustainability of this iron and steel production. So how will it become the sustainable? See, if India is a developed country and we have a scope to develop it, we don't have the new technologies, so definitely those who are industry, they can take the new technologies from the developed countries and they can use it. So definitely again, this iron and steel is a most recyclable product. So if we use this recyclable as it is 100%, so definitely we can achieve the sustainable manufacturing. Life cycle assessment report suggests that every ton of steel scrap we save over 1400 kg of the iron, 740 kg of the coal and 120 kg of the limestone. So again, for an average of the production, 1 ton of the steel result in 200 to 400 kg of the byproduct. This include the slag, dust, sludge, other materials. Byproduct today are integral part of the business, and its recycling provides the significant benefits like reducing the landfill waste, decrease in carbon dioxide emission and preservation natural capital. So steel industries are invested in research and technology. So definitely we can reduce the energy consumption per ton 60% weight by mini steel applications and 40%. So environmental, definitely we can reduce that. And again, the water footprint, we use in this industry the more water for descaling and dust scrubbing. So this, if we reuse that water and return to the resource, so definitely. And again, in the global best practice zero effluent discharge, we can use the cyanide bacteria for the treatment of the wastewater in the plant on the on-site for power generation. So by this way, I hope definitely we can move towards the sustainable manufacturing of the iron and steel industry, and we can reduce the carbon footprint over it. Thank you very much friends for listening.